Very good morning to one and all present here. I am Dr. S. Balachandran, Assistant Professor, Department of Chemical Engineering, Savita Engineering College. Today we are going to see the subject is Total Quality Management. In this subject, we are going to study about the Unit 3 Statistical Process Control. In this unit, we have the different topics such as statistical process control, assignable cause and chance causes variations, process capability, control charts, defeats and defective charts, Six Sigma concepts and its applications, reliability concepts, business process reengineering. First, you will going to see about the statistical process control. First of all, you should know that what is meant by statistical process control. It is a series of operation or action that transforms into the input to the output. It's said to be stable process or resulting output is given in the required specification or not or standard quality. But sometimes, certain cases, the stable process is gets disturbed by the poor quality of raw materials or changing into the machine setting or unskilled workers or improper machines. In such situations, the tool or technology is called a statistical process control technology is implemented to reduce these type of variations and get the required quality. First of all, you should know that the what is meant by statistical process control techniques. It is useful to understanding or monitoring the process by collecting the data periodically from the process and analyzing them and taking suitable actions whenever there is a need of the quality as well as the required specification standards. The use of this technique is used to produce the large quantity of the productions with specified control limit, and it used to monitor. It also helps to monitor the process behavior and discover the issues and the internal systems and find the solution to the productions. The main aim of this statistical process control is to reduce the waste, minimize the raw materials, increasing the product quality. And to establish the control manufacturing process by using the statistical techniques to reduce the process variations. Whenever the process is running, there will be a variations will occur. So from which we have to reduce the process variation to minimize the problems and get the acquired quality product. And this variation will leads to better quality. The decrease whenever decreasing the quality variations, it leads to better quality of the product, lower cost, and reduces or minimizing the waste and scraps, or reducing the reworks, and hence it increases the productivity. And this technique is almost used for all manufacturing process nowadays, and achieving the process stability and making the continuous improvement in such quality of the product, and to make the new design or redesign the experiments to make the required quality. And it has the major tools of the statistical process control is histogram, check sheet, and Pareto chart, and the causes and effect diagrams, and process flow diagrams, scatter diagrams, and control charts. And the statistical process control techniques, we have the different steps includes the detection of initially finding the problems, and after the problems we have to study how to control, and the prioritizations. Priorly we have to initial for before running the equipment, we have to analyze, or the in the running section we can found the measures, and if you sort out the particular section itself, and eliminations and charting, and based on the values are taken, and that values are done by the charting. And this is the diagram is called as a control chart. Whenever the in the process running process, collecting data are plotted by the graph, and the variations between the upper control limit and lower control limit and the standard values, we can specify how the process are coming to the standard quality or variations are occurred. So this chart provides information about the stability and predictability of the process with the specified ranges, and also it used to find the central tendency or targeted values and how much variations are occur. And this chart is used for the time sequence charts. Whenever the process is running, we have to complete within the time interval, and that interval is most important for the process in the production section. In the statistical process control have the fundamental data. Fundamental data is nothing but the variation occur in the process, and from the collection data we have divided into two variation data. So one is variable data, another one is attribute data. Variable data is nothing but control chart displays the values resulting from the measurement of the continuous variables. Okay, example temperature, time, and based on this temperature is coming maintaining the standard values, or times are consuming this the times are coming under the specified limit or not, or increasing the limit. When attribute data is nothing but this category of control chart displays the data from counting the number of occurrence or items in the single category. One process will get how much time taking, how much temperature are coming, how much process are completed. So that similar items or occurrences are found, and based on the counting data may be expressed, it the process will come for pass or fail, or the presence or absence for coming to the defeats. And the statistical process control mainly plotted between the upper control, the center values, upper control limit, lower control limit. The samples are collected, the collected data are given for the graphical terms, and the by using the control chart. From the control chart the process are coming in the within the limit or not, that things we can found out. So the second diagram, this is the normal variation process curve. From the process, we can identify the ranges between the lower to higher values. So when the process coming to the specified ranges, then the process are coming for good quality. Now we move on to the next topic is assignable causes and chance causes. Assignable causes, the causes, first of all, we should know that what is the causes. The cause is nothing but product variations. Whenever the product is manufacturing, from that the problems are identified. Okay, the product may be vary because of their causes or problems happen in the process. This variations causes are coming under the 5M and E. M is nothing but manpower, machines or methods or materials or measurements, where E indicates the environment. So the required manpower, required machines or methods or materials or measurements, we can conclude the causes are will be identified, and depend upon the environment. Environment factor is very important for measuring the causes. And the process variation causes are divided into two types. One is a common causes, another one is special causes. Where the common causes are is nothing but it ever present in the process or naturally occurring process variations. This is called as common causes. Where special causes is the effect that must be investigated immediately. Particular section or particular place, the special section, the causes will happen. So that will be identified. And the process variations are mainly calculated for normal causes. The normal causes nothing but temperature variation, material variation, customers differences, feedbacks, or operating performance that should be maintained or monitored. This is the main difference between the assignable causes and chance causes variations. The variations in the manufacturing product, it is the fact that nature or industrial life, even when the production process will design or carefully maintain the difference between two product, we can identify the variations of the two materials. Okay, that will be very large or moderate or small, even undetectable depending on the successful variations. For example, The weight of the particular model automobile varies units, and the weight of the packeted milks, and the length of the refilling pens, and the diameter of the cricket ball. So these variations are mainly found, and based on that, the causes are separated as assignable or chance causes. The types of process variations: common causes, assignable causes. For the common causes, some of the many chance causes or common causes variations essentially in noise of the system. In the all the process, the common causes is nothing but any equipment is running, there will be a noise will have come. So that type of things are is initially called as common causes. Whereas assignable causes or special causes, it is due to the difference between the people or machine or materials or method. So depend upon the peoples, the variations will happen. And we can deeply study about the chance causes as well as the assignable causes. Chance causes, also known as random causes or natural causes or common causes. Even in a well-designed or carefully maintained production process, the variability exists between the product due to some natural or the random causes. Even the process operates under the same conditions, the quality of the raw materials used in the same, and there is no changes in machine setting or operator or environment, there is a specific pattern the variability will identify. Example: the diameter of the ball bearing varies slightly, and weight of the cricket ball, fuel efficiency, all things are we can study. And this may arise due to the inflexibility or aged machines, or variability or purchased materials, or poor lighting, or extent of workers trainings, and non obvious reasons, other reasons. Okay. And the assignable cause is nothing but it is the another kind of variability may be present occasionally or particular section itself, the output of the process. So these causes are not due to the process design, but takes because of the raw material, machine operator, environmental conditions, and other components. So this assignable cause is also known as non-random or natural causes. This will happen in the improper setting of the machines, or worker falling illness, or still continuing work for the continually giving for workers to the equipments. Okay. And shifts are not changing, breakages, and misleading the scale of equipments, and batches of defeats and raw materials, etc., are the main examples of the assignable causes. This variability due to assignable causes is generally larger than the variability due to the chance cause.